Shekhar Manditi, Dr. Oswal ji, Dr. Rai ji, Jayant Sasubudhe and all the distinguished guests and participants here today. I'm delighted to have this opportunity to speak to you, and I will also address the points that were raised by Dr. Oswal in the beginning and by Jayant Sasubudhe. Before I get into the main topic of the Indian foundations of modern science, which is of course rather surprising because as Jayantji said, we have been told to believe that there are no major Indian contributions that are a part of the science story of the past few centuries, right? And we have slowly come to believe that. But before I get into that, as a member of the Prime Minister's Council and as a general observer of the world scene, we all know that it's accepted by almost everybody that in about 10 years, Indian economy as a total size would be the second largest in the world after China's. In fact, already in PPP terms, purchasing power parity terms, India is the world's third largest economy. Right now, China, US and India. And in 10 years, and this is the World Economic Forum for example, India is supposed to overtake US and become number 2. It will be China, India and US in nominal dollar terms. And what this means is that as an optimist, I think all the changes that are needed, and we do certainly need a lot of change in the world of science and technology within India, those changes will take place. And I'm quite sure people are aware of this and processes are being designed for Indian universities to climb sharply higher in the world rankings, because we don't have too many of them according to one of those ranking systems or polls. We don't have too many of those universities right now in the top 500, for example. But all that will change. As the phrase goes, sometimes you may not want it, but greatness will be thrust upon India, even if we don't want it. And we'll have to take charge. You know, we cannot avoid it. We cannot run away from it. In fact, I am a frequent traveler to US and Australia and other countries, and people already in the scientific world and the general industrial world are saying, hey, when is it that India will play a greater role? Because Europe, as we know, is already declining demographically, and there are other fundamental problems there. And manufacturing is almost gone from the US, excepting in certain sectors. And so the world is undergoing profound change. And now, for a variety of historical reasons, science, surprisingly, has become a controversial topic, or history of science has become a controversial topic. People say, hey, why are you talking about ancient science? It creates complications, let's only talk about the present. And in a certain sense, it's true, because the past doesn't matter. We are only talking about the future. And India's future, I'm convinced, and I'm a nobody, but most smart people are convinced that India will be, it's going to be not only the Asian century or the Asian millennium, but India will play a fundamental role. India will be one of the central stories. And I will, by the end of this talk, make the case that it will actually be India driving change in fundamental ways in science. And I hope to convince you by the end of the talk. So I think fundamental changes are on the way. And the reason why we want to do ancient science is not to obsess about it and do chest thumping and see if we're great, but because, as Jayantji very correctly said, for Atma Vishwas, it is necessary to know what the past was. and then move on and not just keep on thinking about what the past was, but to know, and I truly believe in it as a student of the history of Indian science, that Indian civilization was fundamentally a scientific civilization. And again, as Jayantji said correctly, Europeans, in their interaction with India, after all the ups and downs that went on, were prepared to grant India as a civilization of religion. But they were absolutely not wanting to grant India as a civilization of science. And they said, well, science is our domain, as Jagdish Chandra Bose, who IEEE now recognizes as the inventor of wireless, which has changed the world, right? Wireless, radio, everything has changed the world. And J.C. Bose was the person who did that. And it's not an Indian's opinion, this is IEEE, which is recognized that. And he was also the inventor of the semiconductor 50 years prior to its later reinvention. So, so this is sort of very interesting. This is very recent, of course, and this is just one episode. But Europeans generally, and Americans or Westerners, have been reluctant to acknowledge it, especially in the political and the larger public sphere. Because as far as the world of scholarship is concerned, there is no dispute whatsoever about the items that I'm going to list, just as a few romantic stories which will convince you that truly what we acknowledge as the heart of modern science springs from India. Surprising thing, but I hope to make a case. And whatever I'm going to be talking about is not newspaper articles or magazine articles where you can say anything, but these are all peer-reviewed journal articles or encyclopedia pieces, which are recognized by scholars. Okay, now let me begin by speaking of what is generally acknowledged even in Indian textbooks, because I think the problem is not the West, where there's not controversy about these things, but the problem is Indian school books, Indian textbooks, where for a variety of reasons, and I think all the wrong reasons, this information has not been included in the curriculum, and it's not been included because for the wrong reasons. Some people believe that if you talk about it, somehow it's going to strengthen, you know, the wrong tendencies within the population, so let's not talk about it. In fact, I've been interviewed several times by the national media in the last 3-4 months, and some of these interviews are conducted by email. And in one of those interviews, I asked this question: isn't it shocking that some minister should go about giving a speech where he said that plastic surgery was known to India? So I told the interviewer, well, this is true. And when I said it's true, that was not included in the part of the published transcript. Now, I'm not even blaming people for not knowing it, because I believe that most people want to know what the facts are, irrespective of what the political spectrum is, right? So the problem is that for whatever reason, this is not a part of the curriculum. So, in fact, what we are doing right now is a part of this larger exercise. How do we spread information about unimpeachable facts of Indian science so that Indians will be convinced that, well, we are truly a scientific culture and civilization, and therefore we should take charge of the changes that are going to take place in the next 20 or 30 years, where India, along with, of course, China and the US, will be one of the 3 main players in how science evolves. Okay, now let me go back very, very quickly and talk about things which are generally accepted by everybody. In textbooks here, people do know about the invention of zero, and sometimes people speak about Brahmagupta or Aryabhat. and the earliest inscription in Gwalior, I think, is 629 CE or AD, CE. But of course, 0 was also used in binary numbers, right? You have binary numbers in computers. They're all binary numbers. When were binary numbers first devised? I think Laplace in 1690s, that's in the West. But in India, binary numbers were a part of Chanda Sutra of Pingala, which is, Pingala is dated variously. In some Indian books, he's called the younger brother of Panini. And so, but some scholars say, well, he's much after Panini, maybe 200 BC, because Panini is 400 or 500 BC. So we had binary numbers and combinatorics, a lot of mathematics. I think that is generally accepted, that India had a lot of mathematics. Now, what is less accepted, and that's less accepted by the general public because they have not been given the facts, is astronomy itself. For example, counting by 60s, right? We count circle 360 degrees, right? And you would have probably read that this developed in Babylon or Babylonia about 600 BC or thereabouts. But division of a circle into 360 is already in the Rig Veda. I think 1.164, Asya Vamasya. It's already there that you have 360. And the origin of that, of course, is that you have the civil year, which is 360 days. 5 is the additional days. So after a year, you come back to the starting point. And so this is already a part of that. And then scholarship has also revealed that the idea of Rashis, because there are some who think that the Rashis came with the Greeks, and we only had the nakshatras, the 27 nakshatras, right? But the Rashis are also, the division into 12 is also in the Rig Veda. And almost nobody says that the Rig Veda is as late as 600 BC. You know, even the most conservative dating places Rig Veda to the organization to 1200 or 1500 BC. So all these things in astronomy were there in India, and then the various yugas. Okay. Now we also know mathematics and the Indian numeral systems, along with 0, was introduced to Europe by Fibonacci. And Fibonacci has become very famous lately, Fibonacci series, right? You find these structures in biology as well. But Fibonacci, in his own book, says that he took Indian mathematics via the Greeks, which he learned in Morocco. He was an Italian. And then he translated that. And in fact, the Fibonacci series was written by Viraham in about 900 CE, and then Hemachandra Suri about 100 years prior to Fibonacci. And I believe Manjul Bhargav calls it the Viraham Fibonacci series. And I, in my own, I've written some papers on this as well. I called it the Hemachandra series, a very specific generalization of the Fibonacci series. And as we also know, historians of mathematics will tell you that there was a tremendous resistance to the Indian numeral system in Europe, and it took about 100 or 200 years for it to be completely accepted, because a lot of the theologians said that that negative numbers are numbers of the devil, so we should not accept it. Because the moment you started using 0, you could also put a negative sign and do various things. So there was a lot of resistance, and this is generally forgotten. We forget how slow the progress of science has been in Europe itself. I'll also later on suggest certain new unfolding areas of science where something similar is going on. Okay, now let's come to when did modern science arise? When is the beginning of the modern scientific age? According to historians, the modern scientific age or the scientific revolution began with around the time of Newton. And the time of Newton is the late 1600s, right? And the specific discovery or invention, which is supposed to have started the scientific age, was the development of calculus, which was, of course, disputed between Newton and Leibniz, right? And the fundamental idea in the development of calculus is the idea of the infinite series. Because you had, series prior 2,000 years ago in different cultures, but infinite series. Now, in the last 50 years, a lot of work has been published and accepted. In fact, BBC even did a long series on it. And this is the work on the Kerala School of Mathematics and Astronomy, with great names like Madhava of Sangam Grama and Nilakant Somayajan. So this is 200 years prior to the invention of calculus in Europe. We had infinite series. There was an expansion of pi, for example, to 20 odd places using an infinite series. So now there are some people who make the case that India at that time, especially South India in Kerala, there were a lot of Jesuits, and these Jesuits were in constant interaction with their headquarters in Rome, in Vatican, and all of these ideas were going back and forth. And so these ideas, according to this case, and Joseph, for example, in his book called The Crest Jewel of Mathematics or something, published by Princeton University Press, makes the case that maybe these ideas went to Europe and were the inspirational point for the development of calculus. And so to that extent, India did play a role in the very unfolding, the beginning of the unfolding of the scientific age. Because that changed everything. You could then take up problems which were not otherwise amenable to analysis by finite methods. So this is a very important thing. I'm going to talk about three other items which have changed the world from the direction of science. One is, this is the 150th year of the invention of the periodic table. I think United Nations has announced it as the year of the periodic table, Mendeleev's discovery of the table. Now, a few years ago, I think 1990s, I came across this work by this world-famous professor of Sanskrit and linguistics at Stanford University by name Paul Kiparsky, who's also worked on Panini. And he wrote an article where he said, look, Mendeleev, when he was working on the chemicals, right, the elements, chemical elements, and there were a lot of other chemists who were also working on it. And Mendeleev was in touch, or he knew many Sanskritists. He was in St. Petersburg in Russia. And in the 19th century, this is 150 years, this is 1869, right, 150 years ago. Some of the smartest people in Europe were enamored of Sanskrit because of the connection between Sanskrit and European languages. And people were studying the Sanskrit grammar and so on. So Mendeleev was also a student of Sanskrit. And according to Paul Kiparsky, Mendeleev took the two-dimensional structure of the Varnamala of Sanskrit, right? It's two-dimensional, E, K, K, G, etc., right? So he created a similar two-dimensional structure, and then he gave names to 3 or 4 yet to be discovered elements. And he gave them Sanskrit names. He said Eka, Dvi, etc. And he gave them Sanskrit names because he wanted to acknowledge the inspirational point of his discovery. And then these elements, which I've written about, or you can Google it. In fact, I wrote a column on this some time ago, which was actually a reprint of a published paper in a journal. So you can see all those details, and these elements were eventually discovered, which is what made Mendeleev famous, because he had predicted that these elements would be found because of this structure. And so, to that extent, this is of course not a direct contribution. To that extent, Indian knowledge system played a fundamental role. Now, the other area which has changed the world is machine theory. Right? And what do we mean machine theory? Machine theory is, well, a computer is a machine, but you could also have other machines which have certain well-defined rules where you have to use logic, because a machine implements logical arguments which are normally used in our cognitions, right? When we are doing various steps, when we are doing certain inferences, we are using logic. So the beginning of modern machine theory is viewed in the 1850s, and there are three English names, and these names that you, I'm sure, have heard about are Charles Babbage, Augustus de Morgan, and George Boole, and they knew each other. And in fact, according to historians of science, Charles Babbage is the inventor, modern inventor of the computer, digital computer. Of course, you didn't have electronics, but he had a mechanical digital computer, which he built to implement conditional logic, which is based on mathematical logic, which these people created. Now, George Boole, I believe, died in the 1860s or so. His wife, Mary Boole, lived a long time, and in the 1990s she wrote a very famous essay in which she said that, look, these three creators of mathematical logic were part of a study circle in England, which was led by George Everest. George Everest was Mary Boole's uncle. And as you know, George Everest is the guy after whom Mount Everest is named. Why? Because he was the Surveyor General of India for many, many years. And in fact, his house in Mussoorie is still there, although I personally haven't seen it. Last time I was in Mussoorie, somehow I didn't get a chance to visit it. So according to Mary Boole, George Everest, in his long sojourn in India and his visits to England, he had learned a part of Nyaya. Nyaya is logic, right? Yeah, Nyaya Shastra, in India from various pundits, and he had taken it, which is what he had taught these three English men. And then people forgot it. You know, Mary Boole wrote it in an essay. People didn't pay any attention, but then in the 1950s and 60s, a very famous professor of Sanskrit at Berkeley by name Fritz Staal, S-T-A-A-L, he was Dutch, he went back, and there were a couple of others as well, and there were some Indian scholars as well. They went back and looked at Navya Nyaya. You know, you have Nyaya, which goes back to Nyaya Sutras, but then in the, I think, 1200s to 1400s in Bengal and Bihar, arose the Navya Nyaya school, which created a further development of Nyaya, you know, which goes to Gautam, maybe 200 or 400 BC. They created a further elaboration of it, which has been found to be equivalent to mathematical logic, which arose in the 1850s. And therefore, Mary Boole was correct, that indeed there was a development here, which was then taken up in Britain, because Britain had the resources, and then it was to become the foundation of modern machine theory. Now there's another element to modern machine theory, which in fact goes to a much earlier time, and this is Panini's grammar, Ashtadhyayi. Right? As you know, Ashtadhyayi is about 4,000 rules, which describe Sanskrit completely. In the 19th century, because there's nothing like Ashtadhyayi in its in its boldness and its sweep, which has been created anywhere in the world. So in the 1800s, when people were writing books on Sanskrit grammar, there were some people like Whitney, American linguist, they sort of even set him aside. They said, it's too complicated. Why is he even doing it? Why can't we describe Sanskrit grammar in a more natural way, like say English and other grammars are described? But then in the 1900s, after the 1930s, when computer science first arose, Turing machines and the whole idea of a program and how you can solve any problem after you have described it, it became evident that Panini's grammar was equivalent, and this is scholars saying it, was equivalent to the most general Turing machine, to the most general computer program that is possible. And some of the great scholars of the modern world have said that what Panini did is one of the greatest achievements of the human mind. And just imagine, 2,500 years ago, nobody was able to match it. An amazing thing. This is the other element of machine theory. One thing, of course, was the physical hardware where you are trying to implement the logic, which is, of course, mathematical logic, reinvented in Europe, or Navya Nyaya of India, and the structure equivalent to mathematical programming, which is based on, or which is not based on. We are not going to make claims. We don't want to make claims which cannot be defended to all kinds of criticism, but which is equivalent to what was to arise 2,500 years later in the West, right? And which is a part of modern science, which has changed the world, right? Machine theory, it's changed our lives. Okay, now all to the good. But do we have any other stories which are mind-boggling? Now I'm going to tell you a story which is mind-boggling. The year is 1896, and the world's most famous actress is the French woman Sarah Bernhardt. And she is on one of her tours. She was a stage actress. She's in one of her tours to America, and she's in New York. And she throws a party. And at that party, she invites Nikola Tesla, who was then probably the most famous engineer, scientist in America, because he had invented AC motor, which had won over DC motor of Edison. So he's very, very famous. And he also had all these ambitions of wireless communication or wireless transmission of energy and so on. So he was a kind of a visionary scientist. An engineer of Serbian origin. So Sarah Bernhardt invites Nikola Tesla, after whom the Tesla car, electric car, is named, right? She also invites Swami Vivekananda to this party. He was on his second or third tour of America. And we have a record of the conversation. She wanted these two people to meet. So these two people met. They probably went to one of the rooms in this house where the party was being given, and they met, and Vivekananda was to write a letter about it, and Tesla was also to make entries in his diary. So we know what happened. So apparently what Vivekananda told Tesla, he says, look, I come from India, and in India we have a tradition of physics. This is this whole idea. India was truly the world's most preeminent scientific civilization. And all the shastras, like the darshanas, they're also shastras, right? All the other shastras, there are many other shastras, also Ganit and Jyotish and so on. These are the sciences. They're not religion. What has happened recently is that we have said, this is all religion, so let's throw it out, because we can't have religion in the curriculum. Totally wrong. They're all sciences. So in any event, what Vivekananda tells Tesla is that, look, in Vaisheshik Darshana, Vaisheshik Sutra, which is the foundation of Indian physics, we have this conception that the anus, the atoms associated with the bhutas can transform. And at a certain point, under certain conditions, they all transform into energy. So mass should be convertible into energy. So this is what he told Tesla. And Tesla told him, okay, I'm going to do it. And Swami Vivekananda then said, look, if you're able to do it, not only will it help you advance what you're trying to do, because Tesla was this great visionary, he wanted a revolution. He had also this conception of something like the internet, although it didn't have the elements of that where people could communicate with each other over long distances. So it will help you, but it will also change the world, because then there will not be any deficit of energy. So to that extent, now of course we know that Tesla was unable to do, even though he promised him, okay, I'm going to do it in 2 or 3 months, but we know that it didn't happen. Now I'm going to talk about something which is not a part of peer-reviewed scientific history of science literature. There are some individuals, so this is not, you don't have to accept it. I personally also don't accept it. It's just a story. The story is that Einstein's wife, Mileva, was a Serbian who knew Tesla. And Tesla probably wrote to Mileva. And you also do know that there is a big tradition, and you can Google it, that according to, his name was Joffe, he was a Russian, he was one of the editors of Annalen der Physik, in which Einstein wrote his famous 1905 journal article on theory of relativity, and in which also his brief paper on E equal to mc squared was published. He was one of the associate editors. So he claims that when this paper was first submitted, it had 2 authors, including Mileva. But when the proofs were finally done, Einstein dropped his wife's name. And so there's this strong tradition amongst some feminists and some revisionist historians that really this relativity and E equal to mc squared was a joint work between him and his wife, Mileva. And then there are some people who are speculating, not to be taken as hard science or hard history of science, who are speculating that Tesla might have played a role, at least in inspiring Mileva. And then we can further speculate that Swami Vivekananda played a role in this whole sequence. Okay, now we already, Jayantji already mentioned about J.C. Bose. And as we know, J.C. Bose, Acharya Jagadish Chandra Basu, was directly inspired by Vedanta. At that time, Vedanta was also, even Raman, he in his history of science mentions this. At that time, Indian scientists, and there were some great Indian scientists, even though the conditions under which they worked were horrendous. In fact, just to add to the story that Jayantji mentioned, when J.C. Basu comes back to Calcutta, he is appointed at half the salary. I think the salary was 200, he's given 100 rupees. And he's insulted, and he's given a small coterie next to the bathroom, which is where he made all these discoveries. And he refused to accept his salary, but after 2 years, because he was steadfast, then the administrators relented and they gave him his salary retroactively. So, what he did, and the point I'm trying to make here is that he was inspired by the scientific vision that is the very heart of Indian civilization. And which is why I believe that rather counterintuitively, there were great scientists which influenced modern science, not just J.C. Bose or S.N. Bose, from Bose, Einstein statistics, as you know, S.N. Satyendranath Bose sent his paper. It was rejected at a couple of places. Then he wrote to Einstein, and Einstein sort of stood on it or waited on it for about a year or so, and finally translated it and added a section as an appendix, which is how Einstein's name got added to Bose-Einstein statistics. It was S.N. Bose's work. And C.V. Raman and many others who were inspired by the Indian framework of inquiry. India had an epistemology, a framework of what knowledge is, and so on. And sadly what happened in the recent decades is that we have become, we have forgotten what this past was, and we have bought into this narrative that India was only a religious, tradition related to ritual or relating to religious expression of devotion, that is bhakti, and science was external to us. And of course there are people in the political sphere, certain elites in the West, not in the scientific world. In the scientific world there is no dispute about all of these contributions. But there are some people outside of the scientific world in the West who still hold on to this view. And they believe that any suggestion to the contrary is somehow incorrect, which is why their disciples in the Indian media get very worked up, because they are not aware of all of these facts. So I think what is needed as a positive step is for us to have a course, maybe at the school level or at the college level, on history of Indian science, and only talk about things which are acknowledged by everybody, so that all the confusion and misapprehensions about what Indian science is banished, so that we won't have people on national TV, journalists who are well educated otherwise, questioning things such as, well, did India have plastic surgery or not? There should not be any confusion about that, because it's acknowledged all over the world. Now, another thing that has changed the world, modern world, now I'm going to be talking about health sciences, is vaccination, right? And we know, and I wrote an encyclopedia essay on this, which you can, if you Google, you'll find it, you'll find all the details. When the English came, there was a English doctor in Bengal named Dr. Holwell. I hope I'm remembering his name correctly. 1767, he wrote an account of how Indians used to be vaccinated against smallpox, and how the previous year's outbreak, the weakened virus was used to inoculate patients, and these people, these vadyas, would go out into all kinds of villages all across the country. And Holwell claims that vaccination hardly failed 1 in a million. Of course, that's not a scientific statement. I guess he was just saying what he had observed. And as we know, vaccination is one of the most important things that have changed public health. And that also has a Indian origin. That has an Indian origin. And from India, it went to other countries like China. And in the encyclopedia article that I wrote on it for an encyclopedia on science, non-Western science, I went back to Sushruta Samhita and spoke about how at that time itself there's mention of invisible germs and how there is a situation where you deal with these intrusions by weakened aspects of these intrusions. So there was a mathematical, or not mathematical, conceptual basis to vaccination as well. So this, of course, has also been extremely fundamental in creating the modern world as we see it, with all the wonderful certainties that we have about life, because you used to have these infections and they would kill off lots of people in the West, and as you know, in the New World, a large fraction of the population of American Indians died because they did not have resistance, so to speak. Resistance is not the right term, to smallpox, because smallpox did not exist in the New World. Okay, so just a few interesting stories, which I hope you found good starting points for further examination by yourself. But now I'm going to be talking about something which defines, or which will define science as it is evolving now. So we are now, and I'm perfectly understanding of the attitude that ultimately the past does not matter, all of humanity is in it together. So where do we stand now, and where are we going from this point on? Although from a psychological perspective it's good to know, well, we had science, India is going to be a central world economic power, one of the most fundamental powers, so we should be confident in ourselves and also charting out our own directions. Now, in order to frame where science is going, as you know, I work on artificial intelligence and neural networks and computer science. I also work in quantum computers. And this is all tied up with what is the deepest and the most thorny problem of modern science. You know, modern science has done amazing things in understanding the outer world, although there are problems there as well. For example, physics is a problem. Cosmology is this problem that all of physical theories are based on 0.5% of the observed world. We have dark matter, dark energy, which is 95%, and intergalactic dust. So it's only 0.5% of the observed world is at the basis of cosmology, and that is a problem, because why haven't we discovered dark matter or dark energy, right? Those are questions. But generally, certainly terrestrial applications, we know literally everything about the outer world, right? Of course, new discoveries are being made at the nano levels and so on, and those will continue. But the deepest problem that science has arrived at is who is the observer, right? Both in classical physics, the observer is always outside of the framework of physics. You speak about, you know, Newton's laws of motion or gravity and this and that, but you're not talking about who the observer is. Like, the observer is always outside. And the observer is also outside in quantum mechanics, right? You have the observer interacting with the experiment, and as the interaction takes place, the superpositions in the experiment reduce. It collapses to one of the possibilities. Okay, so the observer is the central problem, because in computer science you have models of the brain, or AI. So the question is, will AI machines become conscious? Right. So 2 years ago, SRI, which is Stanford Research International, was given a contract by the highest decision making in the US, and they wanted answer to this question, but they didn't want to be named, so they gave it to SRI. So SRI was the front organization. They gave them a lot of money. They said, put together a team of physicists, neuroscientists, computer scientists, and philosophers. And I was one of those, but 30 odd people. And meet as many times as possible, 8 times, week-long meetings from morning to night, and come up with the answer to this question: what will be the ultimate capacity of computers? Not now, not 10 years, maybe 50 years, 100 years. In other words, the question was, will computers ever become conscious? So we all met, there was tremendous brainstorming going on. And at the end of one of these week-long meetings in Cambridge, where I was, I was the only Indian of Indian origin. These are mostly, they were either Europeans, mostly Americans, and some from the government, from research organizations, because they were interested in finding out what the answer to this might be. So we took a poll. First of all of us agreed that literally everything that human beings do in cognition, right, which is intelligence, cognition is where we are taking these decisions, will be emulated by machines. So we were all agreed upon it, because all that is done can be eventually reduced to a procedure, and if it's a procedure, you can write an algorithm, right, and therefore you could write or implement that algorithm on a machine, and that will be your AI machine, and therefore it will be able to do that. And clearly this is of great interest to decision makers, because this one scary aspect of this is that most jobs will go away, right? Because machines will, if I have a machine assistant who can do something, I would rather have that do it, because that machine assistant would be very reliable, even though my human assistant might also be good at that. So this was one aspect. There was no dispute about that at all. But then the second poll that we took was, will machines become conscious? Now, I was personally surprised when half the people said, yes, even machines will become conscious. And their argument was something like this. They said, look, if we can emulate everything in the brain, of course, you have various modules of the brain, and we can do higher level processing. For example, you can look at what the vision system does, and computers are very good at that, right? They can emulate that, they can recognize with great fidelity. But of course, they cannot model the entire brain, because the number of neurons is astronomically large. But still, many scientists, and these are some of the world's greatest scientists, they believe that at some future time it will become possible to emulate not entirely completely, but to a sufficient level so that this machine itself would then have consciousness. So this is half the people. And of course, I didn't buy it, I didn't accept it. There were the other half who said, no, this will not happen, because the phenomenon of consciousness is something else. Phenomenon of consciousness is the subjective feelings that we have about that we are aware, is different from the cognitions that we do, or the way cognitions, or how cognitions are harnessed to solve various logical tasks. So we believe that that will not happen. And then while we were discussing all this, and very, very interesting discussions, the philosophical underlying aspects of these positions also came up. And as I've already told you, that these people were not Indians, they were Americans and Europeans. And half of them who said that machines will become conscious, it turned out, were also extremely attracted by Buddhism. And their understanding was, in Mahayana Buddhism, Nagarjuna, right, you have shunyata at the end. So they said, well, that is what reality is. At its deepest level, there is nothingness. And out of nothingness arises everything. And therefore, that's what it ought to be. And that is consistent with the epistemology of modern science. This is half the people. And the other half said, no, the observer cannot be modeled in terms of things. And this is really, for those of you who are physicists or who do quantum mechanics or history of science, the orthodox Copenhagen interpretation of quantum mechanics says that consciousness or the observer is always outside of the experiment. Or consciousness is dual. The idea of duality or complementarity is also between the experiment and the observer. The consciousness is always dual. And that is actually the Vedic or the Vedantic position. And as you know, Schrödinger, one of the two creators of quantum mechanics, was a Vedantin, and he acknowledged in his autobiography that he was inspired by the Mahavakya, I am Atma Brahman, that this Atman is Brahman, that this small thing is the entire cosmos, that this experiment is the superposition of all possibilities. This is the takeoff point. So, according to many historians of science, the heart of quantum mechanics is consistent with Vedanta. And this was also known in India. Now, what happened after the Second World War, there was a reaction to this position. In quantum mechanics itself, there have been attempts to model the observer also in terms of materiality. You know, the observer itself consists of is a system, and this system interacts with the other system, but it's failed, it's not being able to explain how consciousness actually works. And in fact, no neural correlate of consciousness has been discovered. And what do I mean by that? When a person is conscious, you can do functional MRI and so on and see which part of the brain are lit up. Depending upon what particular tasks are being made, the points which are lit up vary. So there is no specific place. There are no distinguished areas in the brain which correspond to conscious experience. And therefore, the idea then is that consciousness is apart from materiality, which is also fundamental basis of our Shastras. In fact, even in Vaisheshik Sutras, and Vaisheshik Sutras, you have materiality. In fact, I really recommend, it's very unfortunate that Vaisheshik Sutras, which is what inspired Swami Vivekananda, for example, to have that dialogue with Nikola Tesla, speaks of how all the properties that there are to matter can be traced to motion. You know, it's very modern. But observers are apart, and the interaction between observers and materiality is called samavaya. So it's that samavaya which is where recognition is made. And in many ways there are some very interesting parallels that it has to the way a philosopher looks at how the equations of QM need to be interpreted. So let me try to tie up all of these threads. First of all, my first assertion is Indian culture and civilization is fundamentally scientific. You have these darshanas, for example. They are all complementary views of looking at reality. You have Nyaya, which means logic, and on the other side you have Vaisheshika, which is logic applied to matter, right? Logic applied to expressions is Nyaya. Logic applied to matter, where you look at constituents of matter, is Vaisheshika. And I must also add that in Vaisheshika Sutras, there are 4 different kinds of atoms are postulated, 2 of which are with mass and 2 of which are not with mass. Amazing. In fact, Kannada even says that everything that there is has all these 4. For example, in the various bhashyas that you have, it's stated that if you look at gold and you heat it, it becomes liquid, which means that the apaha atom, apaha meaning water, or fluidity, it doesn't mean water, it means fluidity. Apaha matter is also inherent in the solid form of gold. It just needs to be expressed, right, as the temperature rises. If you heat it even further, it can catch fire, which means that the Tejas atom is also a part of it. And then it decays, all matter decays, which is Vayu. And so the Vayu atom is also a part of it, because everything ultimately goes away. Amazing logical inference based on the most fundamental thought. Now, I would, since you're all scientists, I would recommend to you my own translation of Vaisheshik Sutra, which I did 3 years ago. And it's a book called Matter and Mind. It has the Sanskrit plus the translation. In my view, it's very, very unfortunate that only philosophers of religion have looked at Vaisheshik Sutras. There have been other studies, both in the West and in India, but this is probably the first study by a scientist, by a physicist, if I were to call myself a physicist. So you might want to look at it, and I think it's something that is worthy of further study. We should go back, because that's the source. That's the source of all the Indian tradition. In the Vaisheshika Sutra later on, you also had the idea that you have all these atoms and they form dyads, or dyads meaning duals, or they combine, and that's how from physical matter you go to chemical matter. And Prafulla Chandra Rai does speak about all these structures. There was this amazing stuff. And all that needs to be discovered. Now, and the very future of humanity, I believe, given that computers will play an ever-increasing role, and first of all, jobs will go away, and if you believe that your only matter is being pushed in the West as well, it only leads to despair, which is what explains why there were 70,000 opioid overdose deaths in the United States last year, right? Because I think for modernity, for the modern world to believe that there is nothing but matter and there's nothing else is a dead end, is problematic. And it's also problematic in a scientific sense. And I believe those of you who are active scientists would recognize that there are all these puzzles and problems not only in physics but also in neuroscience. And what are the problems? You have the problems that, for example, just to give you a relevant thing from physics, the whole question of how a lot of modern physics is based on entropy, right? And physics is also based on the idea, looking from the perspective of epistemology, nature of knowledge, on the idea that everything should be reducible, right? Reducibility. Everything should be broken up into the smallest elements, right? Reductionism. And in reductionism, which is why ultimately all theories are supposed to be field theories. So therefore you can ultimately say that at the deepest level, these are all fields, because there you are speaking of it at the most elemental level, right? But many of these theories are based on entropy. Entropy cannot be reduced. Entropy is a property of collectives, right? And therefore, and a lot of scientists don't pay attention to it. And therefore, right now, there is a breakdown, so to speak. You have entropy-based theories. Even in, you have black hole physics, you have entropy of a black hole, and so on, and so on. And so you are doing this, and all of these theories, like string theory and all of that, have not worked out. Supersymmetry has not worked out, and that is the modern crisis of physics. And I think where a revolutionary advance would take place would be for one to go back and try to see how in physics and also in neuroscience, because in neuroscience and in health sciences, as we know, mind seems to play a big role in health, right? Mind, body, medicine. You cannot rule out the role of mind. And that's where the observer once again comes in. So if scientists who work on the edges were to see how do we think outside of the box, and what is required, what needs to be done for the observer to be brought back into the picture, just as the observer was brought into the picture in the development of relativity theory. Right? Prior to that we said, or at least in Western science it was said, speed of light is absolute. Even Newton said speed is absolute, right? And then they discovered that some of these things were relative. I think we are reaching another crisis, the crisis of the 1890s. And now this is a more fundamental crisis because it has implications for not only physics, neuroscience, health sciences, which is a horrendous problem given its costs in the West, and I'm quite certain that similarly the costs are increasing here as well. And you also have this other crisis of health science, that half the experiments are not replicated. That you do an experiment and then you're not able to replicate it, but still people go ahead and use whatever recommendations have been published. So all of these things, I believe, would be, maybe a way would come out where we bring the observer back in. We cannot talk about consciousness, as you know. People speak of the development of a new science of consciousness, right? Now, as we know, these were questions which were discussed in India a long time ago. In the Upanishads, for example, Mundak Upanishad, there is this mention of two kinds of sciences, the apara and the para. Apara are the outer sciences, things, which are the kind of sciences we do in our research, which are the kind of sciences we do when we go to school or college and we learn physics, chemistry, microbiology. These are all apara sciences. But then the Upanishads also say that there is para-vidya. And the para-vidya is about consciousness itself. But you cannot hold on to consciousness because that is like the light, the prakash. which makes everything possible for us, right? So you can only make sense of the para through, if I may use a poetic expression, through the shadows it casts on everything else. And that shadow, for example, one of those shadows is the observer. You know, our mind, our manas, our mind is informed by consciousness, but mind itself is an instrument, right? It consists of memory, it consists of attention. But if we are cognizant of it, I'm quite sure, and think outside of the box, we stand at a point in science and history of human civilization and culture where we are at a point of great possibility, where if we bring it in, revolutionary advances will take place, just as revolutionary advances took place after the end of the 1890s, you know, the whole relativity theory and then quantum mechanics, which were to change the world. In the early 1890s, people thought that everything that was to be discovered had already been discovered. But look, 20th century was so amazing, astonishing, right? In all kinds of things, in fundamental sciences and in technology. I am quite convinced, and I'm happy to be speaking here at NPL, that some such possibility is possible because is imminent, because we are at a crisis point in many of these sciences. And not everybody does fundamental theoretical work, but if one were to apply one's mind here, and for these reasons, I believe India would play a central role, because if you talk about Atma Vidya, which is the science of consciousness, it existed only in India. It doesn't mean that people are different, all human beings all over the world are the same, but here it was the central thing in life and in one's aspirations in life. You wanted to know as much about yourself as you could. And there is a very happy samanvay occurring right now. According to economists, you know, India would be maybe the second largest economy. There would be more resources. I'm quite sure Dr. Aswalji, NPL and other organizations will get a lot of more money. And then if you're also ambitious, we have got to be bold, look at these problems and be confident, because we are a scientific civilization. We've done science in the past. We've shown the way, and not doing it in a parochial sense. I'm a universalist myself, but it's good to be inspired. Everybody must try to inspire oneself, because we all have dark moments, and we will be able to enter a glorious period. So I believe, I'm an optimist, I will be wonderful, and we all will play a great role in that. Thank you. Dhanyavad.
बहुत बहुत धन्यवाद सर। कहा जाता है ज्ञान जब विज्ञान बन जाता है तब आयु से चिरायु हो जाता है। आधुनिक विज्ञान के निर्माण में भारतीय ज्ञान विज्ञान के योगदान के विभिन्न आयामों पर ज्ञानवर्धक और सारगर्भित व्याख्यान हेतु आपका पुनः बहुत बहुत धन्यवाद। अब मैं निदेशक राष्ट्रीय भौतिक प्रयोगशाला डॉक्टर डी.के. सवाल जी से अनुरोध करूंगा कि हमारे मुख्य अतिथि जी का अभिनंदन सम्मान शौर्य और स्मृति चिन्ह देकर दें। और आज के